Right, we're going to move on to a bit of algebra now, okay? So, have a look at this. We have a wire, piece of wire, okay? It's 24 inches long. So I'll just draw a piece of wire. Here we go, straight as I can. Right, it's 24 inches long. We're going to cut it into two parts. One of them's 8 inches, so I'll call this one 8 inches, right? What's the other one going to be? Now the thing about this is I know that the whole thing is 24, okay? So we know that the total length is 24 inches, right? Now if I cut a piece off that's 8 inches, what's kind of left? This piece here. How long is this piece here? Well, if you're just thinking about basic arithmetic, right, you're going to take that 8 inches off the 24 to find out what's left. And that's kind of what you do, don't you? Okay, if I do that, if I take that off, isn't this piece going to be 16 inches? Okay, so therefore, because 8 plus 16 makes 24. So I know one's 8, so the other one's 16. Because, think about it, I knew what the total was, and I took off the 8, the piece that I know, what's left is the 16. Okay, so if we just do it one more time, we've got another 24-inch piece of wire. This time we're going to cut one piece off that's 10 inches. Alright, so that's 10 inches. What is the other part? Okay, well again, what you would say is, okay, I know that my total is 24. If I take off that 10-inch piece that I know about, then surely what's left is 14 inches, because 10 and 14 makes 24. Okay, so that might be, you do things like that in your head all the time. Now what you don't realise that you're doing is maybe just a bit of algebra. So, have a look down here. Again, okay, we have another 24-inch piece of wire. You're getting sick of this 24-inch piece of wire? But this time, look, we're going to cut it into two parts again, but the first part we're going to call X. We don't know what that is, so what on earth is this piece here? Even worse, I don't know what the first piece is. Right, okay, so remember we are just denoting this with a symbol X. Okay, this is the algebra. Now if you go back up to actually what you saw before, remember this is still 24 inches long. Okay, the whole thing is still 24 inches from there to there. But what did we do to find that other piece? Well, weren't we just taking off what we already knew? If we knew that was 10, we know that's 14. Okay? We take off the 10, we're left with 14, and 10 plus 14 will get me back to the 24. So if I'm taking off that 10 from the total, why don't I just take off that X from the total? Okay, what I'm trying to get at is that is the second piece if the first piece is X. Think about what you would do with numbers, right? Same thing. So this is just an algebraic expression. If one piece is X, the other piece is 24 minus X, not X minus 24, which a lot of people do. Okay, you know what the total is. If this is X, cut it, throw it away, think subtraction, I'm taking it off. Alright, what's left is, well, what you're doing, you're taking off X from 24, 24 minus X. Alright, so that's how you do that. Now then, think about it. Again, if I go up, remember, if I add those two together, I should get the 24. What happens if I add these two together? X, so hang on, I've got X. The other piece is 24 minus X. So these are the two pieces. There's one, there's the other. Okay, well, can you see what's X? Take away X, gone. What you're left with is the 24. I've just proved that if I add them together I get 24. Okay, so that's you doing algebra. Maybe you don't know it, okay, but there you go. But think about it. Think about using real numbers. How you would do it with the real numbers, just do it with the letter X in some ways for this, okay? That's algebra. Now when it says what's the reasonable replacement values for the variable X, well, think about it. It's 24 inches long. X can't be 25, all right? That's too big. How can you cut a 25-inch piece off a 24-inch piece of wire? X can't be 0 because they're not cutting the thing, all right? 24 inches. I cut nothing off. I just asked you to cut a piece off. All right. So anywhere between 0 and 24, you can kind of call the reasonable replacement. You can't actually have 0 and you can't have 24 because then you wouldn't have cut anything. Okay, that's just one of those kind of, little questions. Just think about it. That's all it is. Okay, so an algebraic expression in the variable x, that's what you created. Let's have a look at something else. Okay, right, now then, you've got 8 dimes and 6 quarters in a desk drawer. Okay, 8 dimes and 6 quarters. How much have you got? Well, again, you can order that in your head, can't you? Okay, I've got 8 dimes. What's a dime worth? It's worth 10 cents. Okay, I've also got 6 quarters. What's a quarter worth? It's worth 25 cents. And that's the kind of thing you would do. You'd say, okay, 8 dimes, okay, that's 80 cents, isn't it? So that's 80 cents. 6 quarters, you'd do it 6.25, you'd say, oh, that's $1.50. Okay, so $1.50. So I suppose I should write the 80 cents as no $80. Okay. When you add that together, what's that? Is that $2.30? Yeah, kind of. You've got $2.30. Okay, in your pocket, wherever it is. All right. Now then, here we go. Supposing I say to you, I know I've got 8 dimes, I know I've got 6 quarters, and I know what dimes and quarters are worth. Suppose you've got D dimes and Q quarters. Well, I still know what they're worth. A dime is worth 10 cents. Okay? Just like I did back up here. Okay? Now, how many do I have? Well, in the previous question I had 8. This one, I don't know. I'm calling it D. Well, in that case, just write the D in front. Okay? There you go. What's the difference between those two? 8 times 10 or D times 10? I don't actually know how many I've got, but I know the dime is 10 cents. So with quarters, okay, I know they're worth 25 cents, just like above. Okay? How many do I have? I don't really know. Well, I know I've got Q. There you go. That's what I would write. Now, normally, the expression we write for this, we always put the number first. So actually what you've got here is 20. Whoops. I'm saying dimes first, so I better call it 10. All right. So we know we have, and this is just the algebraic expression, 10D. Notice I've just put the number first, the letter second, plus 25Q. That's the expression for me saying, okay, right, how many dimes have I got? How many quarters have I got? Put it into there. You'll come out with the answer for the amount of money you've actually got, okay, what it costs. So if I look about it down below here, so if I have 14 dimes and 21 quarters, what we're saying here is 10, what's D? It's 14. I'm just putting the 14 where the D is, and I'm going to put the 21 where the Q is, because that's the number of coins, not what they're worth. Okay, a quarter is worth 25, so that's 21. Okay, and I would just put that on my calculator. Okay, and that's what I would have worth. But here's the important thing. There you go. That's the expression I created. Based on that, I mean, you could have used that one as well. It's just we tend to put the number first and the letter second, not the letter first. But look at these two. What's the difference between me doing that and all that up here? All I'm saying is I still know I've got a 10, I still got a 25. I knew I had 8 dimes and 6 quarters in the first. I don't know this time. All I can represent that number with is a D dimes and Q quarters. Okay? Again, you've created an algebraic expression.